Hello guys, welcome to Inside Electronics. So in today's episode, let's take a detailed look at how these kind of mosquito repellers work. Now you may be familiar with this particular brand, especially if you're in India, because this is the most popular brand in India, and this one especially has two different modes in it that you can select. So the usual mosquito repellers will look something like this one right here, which is just in a basic version that does not have any active circuitry to turn on and off like this one. So this one is a very basic one, and as you can see, this is also from the same brand. It's also from the brand Goodnight, and this one is a pretty old unit. You can see the date code, it's 2006. It's made in 2006, so it's a really old unit. But today let's take a detailed look at how this thing works, because the way this thing works is really interesting. And conveniently enough, I have already taken about one of the similar units, and I have the internals right next to me, so I don't have to take apart this one, and both of them work, by the way. And the obvious difference is that this one is not having this plastic shield inside. So and also this one is a little bit upgraded version. And the way this thing works is the chemical that contains the active repellent thingy is filled inside a cartridge, and you're supposed to plug this in and twist it to lock it, and it has a wick inside that bottle. And once this thing is heated up, this entire thing, this is a PTC element, by the way, this is a positive temperature coefficient thermistor thing. So what does that do? It means when you turn it on, the resistance will be much lower, and so the current flows and it heats it up pretty quickly. And once the current starts flowing and it heats up, the resistance increases, and thereby reducing the overall current flow, and that's how it reduces the power consumption. So when you turn this thing on, the power consumption of this thing is really high, and once it gets heated up, the power consumption will be really low. And for example, this one is rated at around 5.3 watts at 230 volts, 50 hertz. And similarly, this one is also rated for you can see that where is that? Yeah, there it is. This one also has a rating. It says 5.3 watts right there. It's see. So the way this thing works, let's assume that this is a wick and this is inside the chemical bottle, and once the wick is like that, this entire thing will heat up, and the wick and this metal part will not be in contact, will not be having any physical contact, but it is in the vicinity. And once it is heated up, the wick gets really hot, and because there is at distance, there is a separation between there is a gap between the heating element and the wick, the heated air will always rise up. So once the air gets heated up, what happens is that the hot air will rise up, pulling cold air from underneath. So what happens is that the chemical will actually get sucked up to the tip of the wick, and the heat from this thing will actually vaporize that chemical, and the heat itself will transmit the liquid to the air, and it uses cold air from passing from underneath the machine to actually do the transferring of chemical to the air. And that is why these things have a lot of air gap inside, because it needs that cool air from underneath to actually take the vapor away from this and spread it inside the room. So that's how basically this thing works. Now the way this particular machine works is, the speciality is it is having two different modes, and the circuit itself is really simple. If you take a look at this thing right here, you can see the element has three terminals going on. Let me actually show you a picture of the element in detail. Let me just bring my tablet in. So this, if you take a look at the screen right now, this is the actual thing. This is the element that looks like, and you can see it says PTC thermistor right there, and this is how usually it comes. And inside this thing is the actual ceramic disc thing. And you can see the specification. This one is for this particular thing, but still it is generic, and the specifications will be common for most of the time, most of the elements. And it says ceramic heater with frame of liquid or solid electric mosquito repellent. That means you can use it with solid, and sometimes you get a flat type where you put a chemical disc on top. And the surface temperature for the round type, which means this particular thingy is around 105 to 125 degrees Celsius. So that is enough to vaporize that liquid. And the flat type, the one you put a disc, a mat on top of, and that is really hot. That's 155 to 185 degrees Celsius. That's really hot. And you can see it is available on different techniques and something. And this right here is the specifications for it. And the thing we are interested in this is this one. It says central temperature 115, resistance, take a look at that, 800 to 3.5 kilo ohms. That is a cold temperature. That is a temperature when that is cold. It's around 800, and that means the current flow will be huge, and it gets heated up really quick. Once it's heated up, because it is a PTC, it's a positive temperature coefficient, the resistance is going to increase to around 3.5 kilo ohms, and that reduces the current flow and thus reducing the overall voltage. So yeah, that's so the circuit diagram for this thing is really simple. As I said, the disc inside is like just a coin. It's like a tablet. It's like a tablet that you eat, the medicinal tablets, like the pills. It is shaped like that, and inside this one you can see three different connections, two separate inputs and one common output. That means two of them are in series, like two of them are connected in such this way. I will just draw it here. So it will be like that. This is the round pellet. So from the top it looks just like a disc, but it is having certain thickness like this one. So in this particular thingy, it is having, this will be the metal contact on top of the first disc, and this will be the second disc, and this is the connection for that, and this is the common wire. So these two, I don't think that is in focus. So these two are the heating pads which are kept inside, which must be inside these two locations right here. And these top wires are the yellow wires, those two, and this common will be that one right there. So you can turn them on and off individually. So let me just, camera is too far. Let's just bring it down. Yeah, that's much better. So this particular one has this fuse attached. This is a thermal switch. This is a ST22F4. This is a temperature switch. This is a thermal cutoff right here. So this is not an electronic component. This is a mechanical component. So what happens is that once the temperature is up to certain limit, based on the specification of this particular fuse, this actually is a bimetallic strip inside. This is a bimetallic strip which looks something like the thing that you can find in old tube light starters. So once it gets heated up, the bimetallic strip opens up. I'm telling about this one right here. So when this is heated up to a specific point, based on the specification of this particular switch, the bimetallic strip opens up and it releases the contact. And the circuit diagram I will just show you guys. And this is a bimetallic, a dual color LED which turns on in red and green colors based on which position the switch is. So let me just bring the circuit diagram for this. And once again I'm going to turn off the lights, because otherwise it's going to completely okay, let me just, yeah, this right here is the, let me just focus on it. It's a circuit diagram. This is the input that is coming in through these two wires. Yeah, that's fine, I believe. So this right here, this 2 pin is the input that is coming in like this, and these two are the PTC elements. Then now this is the equivalent symbol for the diagram symbol for PTC elements, and this is the bimetallic strip, that this thing right here. So, and the circuit entirely is very simple. This is the entire circuit diagram. This is the bimetallic bicolor, this is a bicolor LED, and which is that one right there, and those two diodes let me just show you those two diodes are these two diodes right here, this one and this one, and those diodes is actually just for providing the DC voltage for this LED to glow, and this is a current limiting. This one right here is this is a 10 mega ohm resistor, and that is for current limiting the LED, and these two is a heater element. So what happens is that initially when you turn this on, this switch will be closed. That means no matter how you turn no matter which position the switch is, let's say the switch is in now in down position like this one. So usually during the down connection, you can see from the back of the circuit, if it can actually focus on that, the bottom is actually this yellow wire goes into the middle one, and if you switch it down, the middle one is connected to this one, so which means one of this is connected. And if you turn the switch to the top position, the middle pin is connected to that pin, and which in turn is connected to the next PTC element. And you can notice that the switch is only connected to one of them. There is no connection to both of them. See? But that is completely defeated by using this one right here, because you can see this is the position. When you flip the switch up, we focus on that. Flip the switch up, the current is going to come through here, goes through here, and it is going to turn on this particular element. Because it is not connected to here, this will in theory will not turn on, and the current can actually flow through this and heats it up. At the same time, the current will flow through this diode, which will turn on the red LED, and that goes to here, which turns this one also on. But because of the presence of this thing right here, initially when it is cold, as I mentioned, this switch is in closed position, which means irrespective of the switch position, whether it is here or here, this one will turn on both of the thermistors when this thing is first turned on. Because let's say this one is, the switch is to here, and in theory this should only turn on this PTC, but because this one is closed, the LED will actually, the current will flow through here and goes through there, and then it will goes through this switch, and this PTC will also turn on. So initially both of these are on, which gives an extra boost when for heating this whole thing, because during the initial turn on is when you need the most heat, because the wick inside the bottle will be cold, and you need, if there is only one of these active at a time, you won't be getting sufficient heat output in a much short time, which is necessary to evaporate the liquid. So what they did is they turned on both of these elements initially, whereby creating a lot of heat in a lot less time, thereby whereby heating the wick much faster, and it creates a lot of initial effect. But as I mentioned, once the temperature hits certain point, this bimetallite strip will open, which means then there won't be any current flow through this position, which means only either one of the PTC is going to be turned on depending on the switch position. And you will ask, what happens to the LED? Because this is a red LED and this is a green LED, and when this if this is on, then it should turn on both of these LED, right? Absolutely, because when you turn this on, what you are going to see is not red, not green. It's going to be a kind of orange color. That's because both the red and green are on initially. Only after a couple of seconds, based on the switch position, when the switch opens, the LED will actually be changed to either red or green. So that's how they achieve the initial strike. So now I don't have a proper thermometer to measure up how much will be the temperature, because when both of these are activated, if individual ones are capable of providing around 100 degrees Celsius of heat on its own, then combining both of them for the initial turn on, I think it's going to create a lot of heat. And also because both of them are PTC elements, the initial current draw will be huge, because both will actually have to consume the high power, and once it gets heated up, both of them will consume much less power, and subsequently when one gets turned off, it is going to draw even less power. So that's how they managed to bring it down to around 5.3 watts as this thing mentions. But if you measure it initially using a power meter, the power consumption will be way up, like it will be around 60 something watts initially, because I don't have a power meter, because as I always say, I'm on a budget. I don't have enough money, and my channel is demonetized, and I don't have enough money to buy a proper testing equipment. In fact, the whole testing equipment I have is this multimeter right here. So now enough of these circuit diagrams and things. Let me just show you how this thing works. I'm going to turn this on. I'm going to bring the tablet out of the way. And by the way, if you're saying that if I'm really poor, then how can I afford to buy a tablet? It's because I got it as a gift from my uncle. He heard about my YouTube channel and everything, and he just donated that to me. He just gave that to me for free. That's it. So now enough of talking. Let me just measure the resistance for you guys. So as I'm going to use this multimeter in the 20k ohm, and I'm going to just see, I don't know which position switch is right now, so I'm just going to measure the initial resistance, and this should be the proper way. And now I'm touching the first one, and it's showing 4 kilo ohms, and the next one is also showing, the other one is also showing around what, it's also around 4 kilo ohms, I believe. Yeah, there it is. It is 4. It's not making good contacts right here. It is also 4 kilo ohms. So now let's heat this thing up and measure the resistance then, because in theory, because it is a PTC element, it should actually, the resistance should decrease. And hopefully I can show you the LED color also, because initially, as I said, both the LEDs should turn on. I can show you this thing kicking into action from its sound. I don't know how well you will be able to hear it, but I will try to be as silent as possible so that you can hear the click. You can see it is now, the camera is showing it as red, but it is not red. For my eye it is orange. That is because both of them are now active. I can show you that by using the multimeter. I'm just going to set this to 750 volts. I'm going to measure the voltages across. I'm going to touch both the connections. I'm going to touch one in right here, and this reading that you're seeing is from one terminal of the PTC element. It is showing 240 volts. And this one right here, you can see I have changed my probe, and that is also showing around 240 volts. That is because both the PTC elements are now turned on because of the presence of that thing right there. Now I'm going to attach this fuse to it. Yeah. Now I have pushed the fuse towards the I don't know, can you see that or not? Have to be very careful with this because live, and I'm messing it with that. I'm making contact with that, so that thing, it is really hard, guys. It is really hard. Yeah, now that is actually in contact. Let's just wait.
A few minutes later.
That is as close as it will actually see. Wow. Did you hear that click, the clicking sound? And did you notice the LED is now green? See, the LED is now green. That means if I measure it now, let me just do it again. You just look at the meter reading right here, okay? Let me just focus on the meter reading, and if I'm going to measure the voltage, and you can see it is showing 240 volts right there. But if I measure there, wondering where am I actually touching. So as you can see, I have rearranged the board in a way that you can actually see what I'm doing, and if I close it you can see the LED is green, which means if I measure across it, only one should be active. And by the way, the position of the switch, the input pin, which is a center pin, that this one right here, is connected to this terminal right here. So the other one should be showing nothing, or it should be just floating. So I'm just going to measure the voltage. It says 250 volts right there. That is because that is the active terminal, that is the active element right now. And if I attach the probe to the other one, which is right there, you can see there is no voltage across that. There is no voltage connected to that terminal right there. Let's just measure across that terminal, and no, there is no voltage across that one right there. See? So that means only one terminal is active, and from this diagram you can see, if I touch it like that, you can see at the moment now the LED has turned to red. That is because the thermal fuse is moved away and the switch is now cold enough, so it turns on both of the terminals right now. So if we measure now, it should show the continuity, it should show a voltage between those two. But when the LED is green, that means only either one of these is connected to AC, means this is common ground, and either this one or this one is connected to ground. So when you measure across the connected one, it will show 230 volts, and when you measure across the other one, it is showing nothing because it is not connected to anything. Let's measure the resistance now. Should be, in theory, it should be very high now because it is a PTC element. Let me just unplug this wire really quick, and let's just measure the resistance. I'm bringing in the meter. Hope you can see all these things, guys. Let's just measure it as a whole. Is how much is that? So let me just measure it across one of that, and wait, what? It's in 20k ohm range right here, and look at the reading, 1.3 kilo ohms, and the other one is also 1.3 kilo ohms. That's actually the opposite of what should happen, right? If these are positive temperature coefficient PTC elements, so the resistance should increase when it heats up, but here it is actually reducing it. I'm wondering whether they are using the opposite effect. I mean, is that an NTC inside? But no, it cannot be happening, because if it is an NTC, the resistance will go down so much and the current will increase and the power consumption will be much higher than the stated 5.3 watts. So guys, I'm actually wondering why they are doing this circuit, because is this possible scam, by the way? Because as we have just measured by using this meter, it's still hot, but I can still hold it. Oh, that metal is really hot. As we just saw by using the resistance meter, both the heating elements inside, these two heating elements inside this thing, are of the same wattage. If that is the case, then why the need for this switch right here? Because in both the normal mode and in the active mode, as they are claiming, as they are mentioning in the device, what it does is it just turns on either one of these at different time periods. But because both of them are of same watt, the obvious temperature, the temperature that is going to be created at this area will be the same, because let's say this is a 5 watt heater and this is also a 5 watt heater. When you turn it on, both of them are on and it is now creating 10 watts equivalent of heat. And once the switch is once the fuse is active, gets activated, that means when the switch is off, when the thermal switch is off, this one right here is off, only one of the 5 watt element is going to active. That means the heat generator will also be the equivalent of 5 watts. So irrespective of whether you are putting the device in normal mode or active mode, you are just producing the same amount of heat. So I don't actually understand the way this thing works, unless the resistance is difference between the resistance is really small or the meter is showing something crazy. I don't understand why they are doing that. If both of them are of same wattage, then why there is a need for this switch? And the way that I think they're supposed to work is either one of these has to be of higher power. Let's say this one is of 5 watts and this one alone is 10 watts. So when you are turning this in the normal mode, you are turning on the 5 watt one, so it produces less heat, so it's less effective. So when you want to the active mode, you are turning on the high wattage one, so it produces more heat. If that was their idea, then I don't understand why they are using the same power heating element inside. So I guess there is only one way to find out if this is the case with all these meters. As I mentioned, this one is a really old one compared to this one. This is a recent model. So in my next video, I'm going to compare both of these. I'm going to take this one apart and let's see if this is the case with this one also. So in my next video, we will compare this thing, both of these, and we will see what makes them tick, what makes this thing tick, and is the circuitry same, is the resistance same, or what the theory is same, or was the theory that I said is what they were trying to introduce in these machines. We will see all that in my next video, so do watch that. And in a later video, I will completely tear this thing apart, this one apart, and we will take a look at that one also. So since this video is getting really long, I'm stopping now. So anyways, thanks for watching guys. See you in my next videos.